So this is our start to chapter 3. This is section 3.1. So this is all about section 3.1. And this is about identifying types of angles, or angle pairs as they call them, okay? So parallel lines. I'm sure everybody knows what parallel lines are from Algebra 1, but parallel lines are coplanar lines. They are coplanar lines, which means that they're on the same plane. That means they can be drawn on the same exact sheet of paper. So if you think of a set of parallel lines, they would be able to be drawn on the same sheet of paper. Like if my hand was a plane, I could draw 2 lines on my hand. But they are coplanar lines that never intersect. They are coplanar lines that never ever intersect, which means that I have one line that goes like this and another line that goes like this, and those 2 lines would never ever touch. Now, obviously my drawing is not perfect, because if I extended this line forever and I extended this line forever, they would cross at some point. If your drawing is not as good as mine, and I can't draw, if you can't draw, this is the way that you denote parallel lines. You put a little triangle on there just like this. So you put a little triangle in, and that triangle could get colored in. But this is how you show that 2 lines are parallel to each other. Those 2 triangles show that they are parallel to each other, okay? So then we get to skew lines. Skew lines are non-coplanar. These are non-coplanar lines that never intersect. Okay, so these are non-coplanar lines that never intersect. And what this means is, if you look at my hands, right now my hands are parallel because they are on the same plane. Like if you think of my face as the plane, they are on the same plane and they're going in the same direction. They'll never cross. Skew lines are lines that go like this and like this. You'll notice that my arms are going completely different directions now. One of them is going this way, one of them is going this way, but they would still never ever cross with each other. So the way that you can draw skew lines is you can kind of draw, if you want to, you can draw a plane like this, and you could draw one line that's on the plane, which obviously that shows it's on the plane, and then you could draw another line like this, and that line would never ever intersect with that plane because it's not on the plane. They're going different directions. But if you think about skew lines, you could really draw skew lines and try to, like, if you wanted to, you could draw like this and then make dotted lines after it. But that would show that they're not on the same, they never cross. This point right here is not ever a point because there's a line here and a line here. Those lines never ever cross with each other, okay? Perpendicular lines is something that we've talked about quite a few times, but they are the perpendicular lines are lines that meet at a right angle. So they look like this, they cross like this, and then they have a right angle here. Now that means that every single one of these angles is a right angle. You don't have to mark that, but every single one of these would end up being a right angle. Those are all 90 degrees, every one of them. Also, perpendicular lines, this is a question that got asked quite a few times yesterday. Perpendicular lines are lines that can be drawn or notified like that. So like you could see AB is perpendicular to BC. So you could see something that looks like that. This symbol right in the middle means perpendicular. That's what it means. Okay. Now a transversal is a line that intersects 2 or more lines at different points. So it's a line that intersects 2 or more lines at different points. So I could draw 2 lines like this. So you see how I have 2 lines that are on the same plane. They are going in the same direction. If you think of the box as the piece of paper, a transversal is a line that crosses those things. This thing is the transversal. Wow, that was bad handwriting. So this is the transversal. So this thing right here is the transversal. Notice how it crosses each line like this. Okay? So more examples of what a transversal could look like. I could have 2 lines like this. This is not a transversal because it's not intersecting 2 or more lines. If I drew a red line in like this, notice how that red line is crossing 2 different lines. I could also have a bunch of different lines, and I could still have a transversal that crosses all of those lines. So the line that crosses multiple lines is called the transversal. Does anyone have any questions on anything so far?
Oh, what was the skewed lines image
Skewed,
or picture?
Skew lines looks like this. So it's, and if you think about it, the best way to think about a skew line is with your arms because it's easier to think about it like this. If you have one line going like this and another line going like this, notice how they're going two completely different directions. One of them is going horizontally and one of them is coming towards you, right? They will never ever cross with each other because they can't. But they are non-coplanar. Coplanar would mean they're like this. Non-coplanar means that they're like this. So that means they can never ever cross with each other no matter which direction they go, because no matter what, they're never going to cross. Okay? So let's move on to the next part, which is the parallel line postulate and the perpendicular postulate. So this is the parallel and the perpendicular postulate, which these are pretty straightforward. It's not really a crazy idea. It's just a thing that we have to know. Okay, the parallel line postulate means if there is a line and a point not on the line. So I'm going to draw that over here. If there's a line, if there's a line and a point not on the line. So that's what I drew, right? So I guess if you want to, you can think about it like this. If there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. So what that means is if I redraw my initial picture, and then there is one line that's going to be parallel. So this line right here would be parallel. It's impossible for me to draw another line that's parallel, but these two lines, so I'm going to draw my triangle, and I'm going to draw my triangle. Those two lines are parallel to each other because they go through one point and they are coplanar and they go in the same direction. Okay? The next one says if there is a line and a point not on the line, it starts the exact same way. If there's a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So I'm going to again draw the same thing, same picture. And then I have my perpendicular line, which is going to go like this, and it would make a right angle. So pretty straightforward. It's just saying that if there's a line and then a point that's somewhere else that's not on the line, you can draw a parallel line through that point. If there's a line and a point somewhere not on that line, you can draw a perpendicular line that goes through that. Does anyone need more time writing those down? All right. So, never been here till 9:30. Okay. So, going to the next thing. This is where all of the important stuff happens. So this right here is where all of the important stuff is. And I'm actually just going to write right on this sheet so that I don't have to keep moving out of it. But I'm just going to write right on this sheet, I hope. I think it lets me do this. Oops. Let's see if I can do this. No. Okay. Give me 1 second. I just want to make sure that I have everything easy to see. Come on, let me do this. There we go. All right. So now this is all specifically talking about one very specific instance. Okay. It's talking about something that is very, very important. And what I'm going to tell you right now, this is one of the most important things that we ever have to deal with in geometry. So if you have to put a star and an exclamation point and circle this about 10 times, you need to understand that this is extremely, extremely, extremely important. So this stuff right here is super, super important. You guys are going to have a project over this. You guys are going to have a You guys are going to have a test on this stuff. You guys are going to have to know this stuff for chapters to come. This is not just a one-time like, oh, okay, we can just see it and then be done. This has to be something that you know. All of this is going to be talked about by something that looks like this. 2 lines and a transversal, okay? This line right here, obviously we should know by now, is called the transversal. So these are the angles talked about by forming a transversal. So angles formed by a transversal. So if you notice, there are really 8 angles here. There's 1, 2, 3, 4, 5, 6, 7, 8 angles. We are talking specifically about the angles here, okay? Now we are talking specifically about pairs of angles. So if I'm asking you to deal with angle 1 and angle 5, or angle 2 and angle 7, or angle 3 and angle 6, if I'm asking you to deal with 2 specific angles, you have to ask yourself these questions, okay? Now the questions that you're asking is, are they on the inside or the outside? So they could either be on the inside, or they could be on the outside. That should be your first question. Are the angles on the inside of the thing or the outside of the thing? Okay. So if they are on the inside or the actually, hang on. Time out. I'm reading this wrong. My fault. So first question it asks is, are the angles on the same side or opposite side? So you either have the option of the same side, or you have the option of the opposite side. Now, what it looks like, or what it's talking about, let's say that I'm dealing with angle 1 and angle 7. If I look at angle 1, notice how angle 1 is on the left side of the transversal, right? Angle 1 is on this side of the transversal. Angle 7 is on the right side of the transversal. It's on that side. So right now, they would technically be on opposite sides of the transversal. Angle 1 is on the left side, angle 7 is on the right side. So that's your first step. See if they're on the same side or see if they're on the opposite side. Same side means they would both be on the left or they would both be on the right. Opposite sides means that they're on the opposite sides. Okay? Now, the next option would be, are they on the inside or the outside? So you have 2 options. They could either be inside or they could be outside. Same exact thing happens here. They could either be inside or they could be outside. Okay? So I'm going to go through and I'm going to kind of work through some examples with you first, and then I want to kind of go through and talk about what these are. Now, if they're on the same side and they're on the inside, these are called consecutive interior angles. If they're on the same side and they're on the outside, they are called consecutive exterior angles. Okay, same side means consecutive, inside means interior, outside means exterior. Okay. Okay, so let me know if you have any sort of questions about that. Okay, so opposite, the word you're going to use for opposite is alternate. So these are alternate interior angles. And then opposite exterior, opposite outside means alternate exterior angles. So I have consecutive interior, consecutive exterior, alternate interior, and alternate exterior. Now, what I want you to do in this thing in the middle, this is a special case. Most of the time that you guys have questions, most of the time it will work out to be one of these 4 things down here. But it could also work out to be something called corresponding. So it could also work out to be called corresponding angles. And what I want you to think of for this one is I want you to think of the word same spot. So I want you to think of the words same spot. So let's go through a bunch of different examples and what we're looking at. And I'm just going to try to pull up some questions and the way that things look. And I'm going to do them over here while I have my flow chart here so I can work through it with you. Okay. So I'm going to erase this part. And then I'm going to go through some examples with you so that we can see what's happening. Oops. So let's work through a couple spots. Okay. Let's do this. Ooh, sounds like my kid just fell down. All right. So let's look at this. This came from the back side of that worksheet. It was, I'm not sure which one it was. I can go back and click it in a second. But what I'm going to do is I'm just going to identify what's going on. Okay. Now, something that you have to do is you have to try and figure out which one the transversal is and which one the other lines are. So obviously, if we look at this picture, we can see that we have two lines here, and then we can have one line that's crossed by or crossing both lines. This line right here is called the transversal. So that line right there is called the transversal. All right. So that being said, what we need to do now is we need to figure out what's going on. We need to follow our flow chart. So we need to follow our flow chart. So that being said, if I'm following my flow chart, the first question I ask is, are they on the same side or the opposite side of the transversal? If this is the transversal, are both of the angles on the left or are both of the angles on the right? So I'm going to let you guys actually answer that question. Are the angles both on the right side, both on the left side, or are they on opposite sides of the transversal?
Both on the right side.
They're both on the right side, which means they're on the same side, right? So right now we're dealing with this side. So this side to me does not exist. These will not be alternate at all, okay? They will not be alternate, okay? So now we are going to ask, are they on the inside of the two lines or the outside of the two lines? The way I like to think about this is I like to think about this with my hands. If my hands are those two lines like this, right? I have my two hands and then I have the transversal going like this. Are the angles going to get smushed by my hands when I go like this, or are they not? If they're going to get smushed when I go like this, that means they're on the inside. If they're not going to get smushed, then they're on the outside. Would those two angles get smushed if I push the two lines together?
Yes.
Yes, they would. That means they are inside. So they are the same inside. That means they are called consecutive exterior. So I'm going to write, consecutive interior. So I'm going to write consecutive interior angles. That's how this whole flow chart works. Now there's some things that are a little bit trickier and some things that are a little bit more straightforward, but it takes a little bit of time to get used to. Okay. Now this next one. This one has a lot going on with it. What I would do if I were you is I would try to ignore this line right here completely. Because that line has absolutely nothing to do with those arrows, right? Nothing. So I would try to block that out with my mind. Now here, how would you describe what's going on? Are they on the same side or are they on the opposite sides?
Opposite.
So think about, remember, this thing is the transversal right here.
Aren't they on the same side?
That's okay. Never mind.
Yep, that's okay. They're on the same side. Now,
Okay.
think about it again. My hands are the lines. Are they going to get smushed? Are they both going to get smushed or no?
Oh, yeah.
Both of them are going to get smushed.
Yeah.
You sure?
Wait, so you're talking about
I
the
think
two lines that
no.
go on this way?
The two lines that are going horizontally like this.
Yeah, they're going that. Yeah. And then
If I go like this, are both angles going to get smushed?
yeah, wouldn't they? What's stopping it from not getting smushed?
To me, this one right here is not going to get smushed by that angle because this line would move up to smush. This line would move down. Does this angle end up getting affected at all?
No.
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 So one of them would not, right?
Oh, okay, I get it. I see.
So this angle would not. That doesn't help us on the flow chart because our angles either both get smushed or they both do not. One of them is not getting smushed. So that means if only one of them is going to get smushed, none of these are going to work. So that means I can't use any of these consecutive interior, exterior, alternate, any of those at all. So can anyone kind of describe to me where those angles look like they are? Do they look like they're in the same spot? Do they look like they're not in the same spot? What do they look like? Like if I go like this, okay, so give me 1 second. If I cover up everything down here, if I cover this up, how would you describe the location of this angle in terms of these? Would you say top right,
Inside.
top left, bottom right?
Bottom right.
You'd
Bottom
say
right.
bottom right? What if I covered up this one down here? How would you describe the location of the arrow down there?
Bottom right.
So you just said the same thing twice, right? They're both in the bottom right. If they're in the same spot, they're both in the bottom right, that means that this is called corresponding. So this angle is called corresponding. Okay, let's go through 2 more together. And then once we get done going through those 2, I want you to just try this. That's why there's going to be no homework today, because tomorrow we're going to have to work through it quite a bit together. So let me erase this. Go away. And let me get 2 more examples. And we can try to work through these other 2 examples. Okay. All right, so let's work through these 2. These are, again, right from your worksheet. So first things first, I see that my transversal is this line right here. This line is the transversal. It's a different looking picture than it's looked the entire time, but this is the transversal. So now, are my angles on the same side of the transversal or not? Are they both on the bottom or are they both on the top?
Bottom.
They're both on the bottom, which means they're on the same side, right? So right now, those 2 angles are on the same side. Now what we need to think about is I have my 2 lines. My 2 lines look like this. If I mush those 2 lines together like this, are both angles getting smushed when I go like this?
No.
No, only one of them is, right? So that means that it cannot be either of these 2 because only one angle is getting affected. So what I like to do next is I like to cross off one of these lines and look at it and then say, okay, where is this angle located? Top left, top right, bottom left, bottom right.
Bottom left.
Bottom left. So now I'm going to do the same thing with the other one. Cross off this. Where is this angle located? Top left, top right, bottom left, bottom right. Anybody?
Bottom right.
So think about it. This would be top left, top right. This would be top left. This would be bottom right.
That's bottom left.
It is bottom left. So they're both in the bottom left, right? So if they are
Yeah.
both in the bottom left, that means that they are in the same spot, bottom left, which means that this is going to be corresponding. Okay, so corresponding. Now this last one is a little bit trickier. Again, I cross off things that don't have anything to do with my angle. So right here, I would cross all of this off right here because that has nothing to do with anything. Does this look like a picture that we've seen at some point in our lives before today even? How would you describe the location of this angle and this angle? How would you describe that? How would you describe that? Where are they located? Next to each other, across from each other, by each other? They are
I'd say
vertical
it's
angles. That's
long.
exactly it. These are called vertical angles. So we're still using the stuff that we used before. Linear pair, adjacent, vertical angles, all of that stuff. Okay? So I know that I went a little longer than I planned to, but I'm going to give you 7 minutes right now to just kind of try and work through the rest of this worksheet. I want you to try this worksheet for tonight. Okay? So I'm going to stop recording.